Today we're going to look at how to spot the difference of squares. So we're going to look at multiplying two binomials whose answer is the difference of squares. We have here two binomials, and you can see it's x plus 4 and x minus 4. So that becomes x squared minus 4x plus 4x minus 16. Now we simplify. X squared minus 16. So we actually lost a term here. You can see the middle term is gone because they cancelled each other out. Minus 4x plus 4x cancels out. And so you notice the middle term doesn't exist. We have x squared minus 16. And that is the difference of squares. You can spot it because that has now gone missing there. And I'll show you how you're going to see from the two binomials whether it's going to result in a difference of squares. This is the rule. We have a plus b and a minus b. So when the sum of the two terms is in the one parentheses and the difference of the two terms is in the other parentheses and they are multiplied, but they are in the exact same order in each parentheses, we have the sum in the one and the difference in the other, then the product of the two is the difference of their squares. So that is how you see it. You just have to make sure that the A is there, the A is there, the B is there, the B is there. Otherwise the signs might be different and then it's not exactly the difference of squares. Difference of squares is the sum of the one and the difference of the other, and they're multiplied to become the difference of their squares. Right, so let's look at this one here. This is the sum and the difference. Okay, so let us have a look at them. Why they would result in the difference of squares. That's x squared minus 9x plus 9x minus 81. And that's going to become, well, first of all, these two are cancelling out. X squared minus 81. And we know the square root of x squared is x, and the square root of 81 minus, well, the square root of 81, we'll ignore that sign for now, is 9. So that's a difference of squares. So there we've just proven that rule which we've just learnt, and look out for it. It's the sum of the first one that's exactly the same as the difference of the second one, and that's normally the difference of squares. We'll look at the next rule tomorrow.